Okay. All right, so this slide, it pretty much covers everything we've been talking about, or certainly, with volumes and pressures and all that good stuff. It covers all of that. And so what we're looking at is we're going to look at the pressures and volumes in the various parts of the heart during all different parts of the ECG cycle, which is the lub-dub contracting of the heart. So let's start out over here. So here we are. Over here we see the pressure of this line here, this sort of low green line and the red line. This is pressure in the ventricles and pressure in the atria. And you can see that there's very low pressure here at the very beginning when we're at the P wave, when the two atria are filling the ventricles. Now, as this thing is being filled, you can see that the ventricles go from a volume of, there's a change in volume of about 70 or 80 milliliters. So basically what we're talking about is we're going to be filling the ventricles, and what did we call that in the previous slide? We called that the preload. So the ventricles, they're going to be filled up, and the pressure that is going to rise in response to that is the preload. And so we can see this preload pressure here is rising in the ventricles. And we had said the ventricles, as this preload is rising and rising, it has to overcome what? It has to overcome the afterload. And we had said the afterload is the pressure, this line here, that is the pressure in the arteries that are going to be overcome. So here we can see the ventricular pressure rises and rises. This is this preload isovolumetric contraction. All of a sudden, it exceeds the pressure in the arteries, and you can see that we start to pump the blood, and the pressure rises in the arteries as well. And so this is representing, it overcomes that 80 and rises, I think on this slide, to about 115, and then it comes back down in the artery. The artery comes back down again to about 80 here. So you can see what's going on, and then even to the point of you get the lub and the dub. I don't think I've mentioned this yet. What do those sounds represent? We have valves that close and bang together at the ends of each of these things, these steps. So when we talked about the contraction of the atria, it's pushing past the atrioventricular valves, the tricuspid and bicuspid, and as soon as it finishes that, they close up. That's lub. And then when the ventricles squeeze the blood past the semilunar valves out into the two arteries, when they close, it's dub. Lub, dub. Lub, dub. It's the sound of the valves closing. That's what you are hearing. So anyway, all of that stuff is up here. It's great information, great fun, right? Yeah. I have former students who tell me they love this so much that they became cardiac nurses. So it is fun to some. All right, so we've already mentioned this, so I mean there isn't a whole lot to mention here, except that there is some feedback information that is being given, right? So we had said you have the autonomic nervous system that's increasing blood, heartbeat and stroke volume, but you're also monitoring stretch in the heart. And so we have what we call baroreceptors. These are stretch detectors that are present in the heart muscle, and when we get too much stress, What does it do? It tells the autonomic nervous system, and the parasympathetic division says, ha, 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 we gotta settle down, young man. You're getting out of hand. We got to slow you down just a little bit so we don't blow up our heart, right? So the autonomic nervous system is monitoring stretch. And so we have receptors. I know they're up here somewhere that we talk about them. Yeah, so we have receptors here in the aorta, which are going to be giving information about how much stretch there is. And the vagus nerve is the parasympathetic, the nerve that is controlling, slowing things down here. Okay, so we've mentioned, and I think a lot of this final slide is common sense. What it's referring to is what are things that affect this cardiac cycle, and it's things like exercise, body temperature. When your body is trying to cool itself, your heart starts pumping heavily. That's sort of the basis for sauna, Finnish sauna. Sauna is the way they say it. It's the correct way to say it. But what happens is your heart starts beating harder and harder, trying to pump blood to your skin so you can dry or cool yourself by evaporation. But in a Finnish sauna, what you do is you add water to the rocks so that you have this high humidity so you don't cool yourself. And so as a result of that, your blood pressure rises and your heart's beating, and it's kind of like the lazy man's way of exercise. It truly is. It's a form of exercise. It's a cardiovascular exercise because your heart is beating. It's also why you don't take that kind of sauna by yourself, because it potentially is dangerous. But it has tremendous, therapeutic health effects. When they study people in Finland, which is the only place in the world where you have a large portion of the population that uses sauna regularly, what they find is that they have increased lifespan in people who regularly use sauna. But you have to be careful. So anyway, body temperature, physical exercise, various ion concentrations are really important. We had said parasympathetic division slows the heart rate and stroke volume. The sympathetic division increases it. We had said that we have receptors, and there's only one thing that I haven't mentioned that's on this slide. I had mentioned the baroreceptors in the stretch receptors in the artery and in the heart. Why does your heartbeat rise? What is the signal that is telling you that your heart needs to beat more rapidly and pump more blood? Well, it ends up it's blood gases. It's low levels of oxygen in the blood or high levels of CO2, carbon dioxide. And it ends up, carbon dioxide is the larger of these two. But blood gases are being monitored in your heart and in your brain. In your heart, it's oxygen levels. In your brain, it's CO2 levels. But all of these are going to be responsible for how rapidly your heart is beating and what the volume of blood. So, So in the next chapter, we'll talk a little bit more about that. We'll talk about how heart rate times stroke volume will give you the amount of blood you're pumping per minute. But that's in the next section. Hey, this is the end of material for test number 2. And so what we'll do is next week during lab, you're going to have exam 2. And then after you've taken that, I will be posting online the midterm. It's the departmental midterm, and you will have a week to take it so you can kind of work with your schedule, and that will be using Respondus with Monitor and Lockdown. So it'll be a regular test, but we're not going to be using any class time to do it. So anyway, I'll get this last group of 3 or 4 videos posted and get all this stuff online. Hope you guys have a good day. See ya.